Okay, welcome back everybody. We're going to do the third class of the Algorithmic Art series, and I'm going to have a great class for you today. I think I'll try and get it to go a little faster. Anyway, that's enough of me. Let's get right to the code. So here we are. We're in Visual Studio. This is where we left off last time. So let me go ahead and run this and press do it. And we have the little, I don't know, a little sunburst type thing. In any case, it's not so interesting. The colors, because it uses a random color for each line, it's almost like too much color. So we're going to start off with making a few changes to this thing, and I'm going to show you some of the new functions I've added in G. Not a big deal. Don't want to focus on that. Want to get right to it. Now, in this line here, well, let's get a color first of all. We'll get a color variable, and we'll set it equal to our G dot get random color. Okay, so that's something we had before, but something else that we didn't have before is I've added a new function to G where I can set color equals G dot change color, and the change color function has two arguments. It has another color and a change factor. So this is sort of how much the color is going to be changed. So we'll just set it to I'll set it to 5. So we won't have, or 6 is fine. So we won't have a lot of change in the color. And we'll change this, so instead of getting a random color for the pen, we will just give it the variable color. Okay, so quick review of the changes. So we set this variable color to get a random color. Then we got a random point for P1. Then we set color equal to G change color, where a change factor of 6. And then we did a pen to this color and then draw lines. So what'll happen is the color of each line will just be a little different from the color of the previous line. Let's see how this works. Okay. That I think is a little more interesting. You know, the thing with computer algorithmic art is it's got random number generators in it, so sometimes you run more than one and see which one you like. So anyway, I think that's more interesting than just having random colors. Let's do one other thing. Is occasionally we will just make the color completely random. So I've added a new function to G, which is useful in computer in algorithmic art. So it's probability. Oh, got to put the G first so Visual Studio can find it. probability. And probability is a function that you give it a value between 0 and 1. Let's just give it a tiny value, like 0.001. I need to make that a 0. Okay, now what probability will do is it'll return a value of either true or false. Now, in this case, I gave it an argument of 0.001, so it'll only return true randomly 1 in 1,000 times. And when it does, we're going to just reset the color to a random color. Okay, so now let's run this, see what happens. Okay, it's hard to tell what it's really doing, but after approximately every 1,000 lines, it completely changes to a new color. And then for the rest of the lines, it changes the color, but only a little bit. We could make it, we can play around with this and let it, if we made this color change factor a little larger, say 20, then there's going to be more change between each line's color. I don't know if that's better or not. The colors are kind of related, but you know what? We can put a probability around this as well. So let's we know that approximately every 1,000 lines the color will I'm going to copy this little bit of code, and we know every 1,000 lines the color will change completely. And what we will do is we will say every 100 lines the color will change just a little bit. Let's do Control X and Control V. Actually, I'm gonna, this thing is drawing a lot of lines. I think I'll make it, right now it's every 5,000 lines. I'll make it every 200 lines by putting a 5 there. And I'll make this every 10,000 lines by putting a 0 here. So it'll keep the same color, but randomly, approximately every 200 lines, it'll change the color a little bit. And every 10,000 lines, it'll get a completely new color. So let's just see what's going on. Yeah, I think I like that better. So let's look at this. So now it's just changing colors a little bit, and every 10,000 lines it'll hit a completely new color. Maybe that was what happened right there. Who knows? You never can tell with random behavior. Now the other thing is, it's more interesting if the artwork is seen full screen. So if I go to the designer, and we're probably going to have that same problem with the properties. Yeah, the properties is empty. It sometimes takes a little while before the property shows up. I guess visual. This is what happens when you have a 7-year-old computer. Um, see if it's ready yet. Properties. Yeah, now it's filled in. And the property we want to change is somewhere down here. Windows style. Do, 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 do. I just saw this. Okay, so the property of Windows state, I'm going to change the Windows state to maximized. This can be done in code, but it's sometimes easier just to use the designer. And now if we compile it, when I click do it, the artwork comes up in full screen. Okay, it's certainly more interesting than just having random colors for each line, but it's still not that interesting. And I want to get into something that I find much more interesting, and that'll be recursion. Now remember, when you're using this as an artist, see, we just have this this one function. I'll get rid of this for now. We just have this one function called draw, and that's all you have to change. If you change the draw function, you'll get your own artwork. Now, what I'm going to do is, you might want to start collecting different draw functions. So I'm going to call this draw 0 because it's the first one. That's how programmers number things. We start with 0, which means I have to go up here, and in the drawing thread, I have to call it the draw 0 function, and then we'll just do it. Okay, so it still works the same. We just changed the name of the function. But what we're going to do is we're going to copy this. So we're going to copy the draw 0 function. And we're going to name this copy draw 1. Okay. And draw 1 is identical to draw 0. So if I go up here and I can go up here and just change the thread. Where is it here? I can change the thread to be associated with draw 1, and that changes it to the new artwork that I'm going to do. Okay, so that's fine. And now I'm going to take out all the code here because I'm going to write a new artwork. So here we are with a blank artwork called draw 1. Of course, if we ran it right now, I gotta kill the old one. So if we ran it right now, the window is simply empty because there is no code in draw 1. Okay, so let's put some code in draw 1. And what I want to do is we're going to start to learn about recursion. And recursion is simply when a function calls itself. And we're going to see what it can do. Now, I've already got some code, and I'm going to save you from watching all my typing. So I am going to open a file, and it's in practice 2. So I'm opening the artform.cs, and this can get complicated. So because now we have two art forms. This art form right here is not part of the project. So I'm going to move it over to the far right so we don't get confused. But in this code that I was trying out earlier, I created a function called circle, and I'm going to bring that in to the code. So Control C, and I'm going to copy this over to the actual art form, the one that's part of this project. Okay, so this is a function called circle. It takes a color, it takes a CX and CY, that's the XY coordinates of the center of the circle, and also it takes a radius. So it's a useful function. Let's just try it out. So I'm just going to say circle, open parentheses. The first argument is a color, and color dot red, we can draw a red circle, and the next arguments are the center of the circle, which I'm going to put it in the center of the bitmap. So I'll just say divided by 2, and since I'm dealing with floating point numbers, I have to put a little f on this, and I'm going to make it halfway through the height as well, so I'll put an f here, and for the radius, which is the last parameter, I'm just going to say the b height divided by 2. So it's going to be a circle that fills the whole screen, so, or the whole window. And now I'll press Control 5 and click Do It. Okay, so we have a red circle. By the way, it stretches the bitmap to match the screen, so that's why it's slightly elliptical. But that doesn't matter. Anyway, it's kind of zen, just a circle there. That's kind of cool. Let's make it a little smaller so that it fits entirely in the window. So I'm going to make the radius half the height of the bitmap, but then I'm going to multiply that by 0.9, and it's got to be a floating point number, so I'll put an F there. I'll put a little space there just to make it more readable. And now if I press Control 5 and I click Do It, we see the little circle. Okay, so that's good. By the way, if you wanted to make it so by sizing the window, you can change the aspect ratio of the circle, but it doesn't change the bitmap. So the bitmap is just being stretched to fit in the window. So we'll just leave that. Okay, now let's come up with another concept, and I'm going to call it a recursive circle. And I'm just going to name it R circle, where the R stands for recursive. And I'm going to take this code here and make a new function. And I will call this R circle. I don't know what I just did. Cursor jumped around a little bit. I think that's the keyboard I use. It's got a little touchpad on it. Okay, so I'm going to make circle. R circle is going to call circle with the same parameters that were passed to it. And so now the drawing should be exactly the same because it's calling R circle with all these parameters. These parameters are arriving in R circle and then immediately being sent to circle, so it should do the same thing. So let's just test that and do it. Okay, so it's still working the same. Okay, so now let's get into recursion. Let's say, what if we defined a circle as actually being 5 circles? Now this is a recursive definition where you use the word circle in the definition of circle. So I'm saying that a circle is going to be equal to 5 circles. Now, if I did this, they would all be the same and they would just draw on top of each other. So what I'm going to do is I'm going to make some changes. I'm going to say that I'm going to have a variable called new radius, and it's going to equal radius times 0.5, and because it's a floating point number, I'll put a little f there. Okay, so the new radius is going to be half the size of the old radius. Okay, now I'm going to use Shift and Alt to make a multi-line cursor, and I will just type NUR and then a delete. So I'm going to use the first circle will be drawn using the regular radius, and the second circle will be drawn using the new radius, which is half the size of the old radius. Now all 4 of these circles would be the same right now, so I'm going to reposition them a little bit. I'm just going to say that this will be moved to the right by the size of new radius, and this will be moved to the left by the size of new radius. This one will be moved, it'll be moved up. Remember that the y-axis works backwards, so it gets larger as you go down. So by subtracting from the center y, I'm actually moving it up, and it wants to auto-complete this, but I'm going to change the minus to a plus. Okay, so this is now, it's not really recursive yet, but we're going to make it recursive. But let's take a look at this, because the circle is made up of 5 circles. There's the outer one that's bigger, and then there's 4 ones that are inside that have half the radius of the big circle and are positioned up, down, left, and right. Okay. Now, that's the basic idea of a circle, is that we're defining a circle as being made of 5 circles. But it's not really recursive yet, because to be recursive, these inner circles would have to also be defined as 5 circles, and So there would be another little circle inside of each of those. There would be another 4 circles inside of each of the inner circles. So in order to do that, I need to make these calls to our circle instead of calling circle. So again, I use Shift-Alt to get a multi-line cursor, and I'll just say RC and then hit delete. So now I'm calling, so this is what makes this recursive. This function RCircle is going to call itself 4 times with different values. And then when those are called, they're going to draw the circle, and then they're going to call themselves again 4 times. And then each of those will call themselves again 4 times. Can you sort of see what the problem is? This thing will never end. Our circle will just keep calling itself over and over, and eventually it'll run out of the stack. And this is the reason that we made the stack. When we made the thread object, we gave it, what did we give it? 2 million bytes? 2 million bytes of stack, so we'd have plenty of room for the stack. But if we just keep calling ourselves over and over, then it's going to eventually blow up. Now what you have to do is you have to say, well, okay, it can call itself like maybe 5 times, but after calling itself 5 times, it has to stop. So I have to add another variable in here, and I'll just call it an integer, and it'll be the recurse. How do you spell recurse? Recurse. Well, it doesn't matter. I noticed there's an option to do spell checking, but the compiler doesn't recurse. There should be an R in here. Recurse level. Is that a C or an S at the end? I think it's an S. Well, whatever. Compiler doesn't care about my spelling. And then what we'll do is we'll draw a circle, and then we'll just say if the recurse level is less than or equal to 0, then in that case we will just return. We won't go on, we won't call ourselves again and again. If the recurse level is 0, we will not keep, we won't keep recursing, well, whatever. In any case, it won't call itself again after the recurse level gets to 0. Now what we're going to do up here is we're going to say that, oh, wrong draw. We're going to say that we have to add the recurse level operator here, and I'm sorry, parameter, and I'll just make it recurse twice so that we can see what it's doing. Later we'll bump it up and it'll get more interesting. Now, these calls have to also have a recurse level. So I'm just going to say comma recurse level. I spelled level with a K. Again, doesn't matter. So -1. And of course I have to add that to all the calls. I think I pressed the wrong key. Okay. So now let's see what's going to happen here. It'll reformat the line if I add a semicolon. If I take the semicolons out, there's probably some easier way to get it to reformat the lines. Okay. I apologize for my typing. Okay, so that looks good. Let's see what's going to happen. The first time this function is called, the recurse level is going to be 2. Then it's going to draw the circle. It's not going to be less than or equal to 0, so it'll jump over the if statement, and it'll go ahead and call itself 4 more times. Now each of these, when it calls, it's going to send recurse level -1. So next time through, it's going to be a 1. So again, it's going to fall through and not hit the return statement. Then it'll come back, and now the third time it calls itself, it'll have recurse level of 1 -1, which will be equal to 0. So now it'll come up here, it'll just draw the circle, and then this if statement will execute, and so it'll return and not recurse again. So that is important for recursion. There's two important things for recursion. You have to have a base case where it doesn't recurse, and you also have to, each call to the recursion has to get you closer and closer to the base case. So this R circle function should do that. Let's go ahead and run this and see what it looks like. Okay, we said it would recurse twice. So indeed, the big outer circle has 4 inner circles, and each of those 4 inner circles, they also recursed, so they have 4 inner circles. And now, oh, I gotta kill that. I gotta get rid of widgets. It's just a nuisance. Close window. Okay, now if we jump up here and make it recurse 5 times, that should be even more interesting. So we'll have little circles inside of little circles inside of little circles, etc. Okay, well that's kind of interesting. Now we could change the colors around so that we get different colors. So let's try that. So right now we're sending it the color red. Let's just send it a random color. So G dot get random color, and so now it won't always be red, it'll be different colors. Now down here, just like we had a new radius, we can also have a new color. So let's just say new color, and that's a variable, but I have to give it a variable type, so I'm going to call it color. Color new color equals, and I think I showed you that change color function. You can go look in the G code and look and see how that works. So G dot change color, and we'll let it originate with the color, and we will put a change factor. Oh, let's go wild and make it 60. Okay, and again, instead of calling it with color, I will call these calls with new color. Again, I'm going to use Shift Alt to get a multi-line cursor. So new color, delete, and now let's take a look and see what happens. Okay, so we can see that there's some different colors there. So some changes in the colors. Let's try running it again. Okay, there we go. Some blues, some light colors that are kind of fading out here, but that's all right. Let's do it again. Okay, so this is interesting. Now it's very symmetrical, and symmetry is beautiful, like a mandala or like a pattern. But somehow I prefer not having too much symmetry. This whole pattern has a certain amount of symmetry in it. So what I'm going to do here, instead of putting it in the center, I'm going to do G dot get random F, and I will just get it some X value that's inside the bitmap, and I will get it some Y value that's just inside the bitmap. So dot get random F. So this time I'll get a random floating value that's in the B height, and so you know what I think I'm going to do also, I'm going to change the size of it to be G dot get randf, and there is a version of getRandF that takes 2 arguments. So I'll say that it's going to be 0.9 at the smallest, 0.8 is fine, and 5.0 at the largest. So we'll have different scales. And just to make it more interesting, I'm going to bump the recursion up to 8. Now, you have to be careful with your levels of recursion. Remember, every function call is going to call itself 4 times. So if I increase this from 5 to 6, I would make 4 times as much work. If I increased it from 5 to 7, I would make 4 squared times more work, and that's 16. And I'm increasing it to 8, so that's 4 to the 3rd power, and so that'll be 64 times as much work. So this might be interesting. Let's take a look. Doesn't seem to be changing color very much. Let me increase the change color factor. What's that semicolon doing there? Is that some artifact of me not typing well? Okay. So, what did I say, 60? I'm going to take this up to 80. Not 800. That would almost be the equivalent of just taking a random color. Probably would be the equivalent of taking a random color. Okay, I like that. By the way, I did make a modification to change color. Let's take a quick look at see what I did to change color. So if we go look at change color, it's not so important. You know, it gets the RGB, and then it changes it by a random number that's controlled by the change color factor, and then it clamps it to make sure that it's between 0 and 255. But then it calls color from ARGB, and this 127 means that it'll be half transparent. If I made this 255, it would be fully opaque. If I made it 0, it would be completely transparent, so it wouldn't show up at all. Let's just run it here with the 255 and see the difference. Okay, so you can see that when something is drawn, it completely covers up whatever's underneath it. And I kind of like the 127 because that makes it sort of halfway between, well, it's 50% transparent. So you get to see 50% the color that it draws and 50% of whatever's underneath it. And so it can just sort of kind of accumulate. Oh, I gotta go kill this real quick and do it. Okay, so I kind of like this pattern, but remember one thing we can do, very similar to drawing the little line burst pattern, is we can go back to the draw 1, which is what we're kind of doing right now, and we can just say while true. So we're going to make this a loop that keeps on going forever, and another closed curly brackets. And an open curly brackets. And I'll indent this to make the code a little neater. Okay, so now let's run this. Oh, same thing. Didn't close the old one. It's always a race to see if you can close it. If not, you just have to rerun it. After it tries a certain number of times, it'll just quit. So now let's do it. Okay, that's kind of interesting. Kind of like it. It's got a sort of a pastel. It's sort of feels like watercolors, maybe a little impressionist. It still has a certain symmetry to it, but because the center point of the design keeps being picked at random, it doesn't it doesn't come off like completely symmetrical. You know, I think algorithmic art, like, of course you can make it any way you want, but algorithmic art, I prefer it not being completely symmetrical, even though there's obviously some elements of symmetry in this. Anyway, that's kind of it. That's the artwork that we have going right now. And I think it's pretty interesting. So I'm going to wrap this class up, and what we still need to do is we need to have the ability to save this to a file, maybe a JPEG or a PNG. And also it would be kind of interesting to see if we could turn this into some sort of video file. Then we could make like these long videos and put them up on YouTube, because that's always nice. Maybe put a little music in the background. This is kind of interesting to me. I could watch this for maybe 5 or 10 minutes. In any case, guys, thank you very much. Again, I'm going to post the code that does all this. Actually, I have already posted the code, and it's not going to be exactly the same as this because I went through this whole class earlier, but I screwed up the way the video recorded. Only recorded like half the screen, or did something weird. I'm just learning how to use OBS. In any case, the code is it's functionally pretty equivalent. So I want to thank you all for being patient with me. And this is the point where I beg you to like and subscribe. And if you really want to be, if you want to add a positive comment or something, you know, say, because I'll tell you the truth, most of my videos don't get a lot of views, and I'm not good at marketing this stuff, and I know the production quality can be a little low, but I think it's a good class, and I think some people would have fun with it. And if you like and subscribe, that'll get the video out to more people. So thank you, and have a great day, and I will see you in the next class.